How's it, grade 11s? So we're still dealing with equations. And today we'll be moving on to solving equations using substitution. Okay, so normally we use the substitution method when an equation will be a little bit complex otherwise to solve. So the best way to do these is to go through an example. Okay, so example 1, solve for x. So you have this 3x squared minus 2x all squared minus 6 times this 3x squared minus 2x plus 5. Now, as you can see, this would be complex because you would have to square this out, so you'd have to FOIL it and you'd get x to the 4. You guys don't know how to solve an equation that has to the power 4 yet. So what we're going to do is we're going to use a substitution method. Okay, so example 1. Just want to get it down here. Okay, so if we go through this thing now, you can see that the complex part would be this over here. Now, this thing here, this 3x squared minus 2x is repeating there and there. So what I can do is I can use the substitution method to make our lives a little bit easier. So what I'm going to do here is I'm going to say let k be equal to this thing that is repeating. So we've got 3x squared minus 2x. Okay. In this original one, wherever I see this 3x squared minus 2x, I'm now going to replace it with a k. So this bit over here will become k squared. Minus 6, that will become a k, plus 5 equals to 0. Now this is a trinomial, which you guys know how to factorize. So that's what we're going to do. We're going to factorize this in terms of k. So we get k, 5, 1, minus. And if we solve it like we do with the other examples that we've done, we get k is equal to 5 or k is equal to 1. Okay, but now the original question was solve for x, and we haven't done that. We've solved for k. So what I need to do now is I need to back substitute for my k. And we originally said that k was equal to this 3x squared minus 2x. So that's what I'm going to replace the k with here. And we get 3x squared minus 2x equals 5. And the other one I'm going to get is this here, which is 3x squared minus 2x equals to 1. Okay. Take the 5 to the other side. And what we have here is another trinomial that we can factorize. Okay. And if we factorize it, we can get 3x minus 5 x plus 1 equals to 0. And again, I can solve for this. So remember, all I'm doing is I'm taking this, setting it equal to 0 and solving it. So if I set this equal to 0, we would get 3x minus 5 equals 0. Take the 5 minus 5 to the other side and we get 3x is equal to 5. Divide by 3, so we get x is equal to 5 over 3. Or solve for this one and we get x is equal to minus 1. Okay, so those are those ones. Now what we need to do is we need to solve for this one here. 3x squared minus 2x minus 1 equals to 0. And we can factorize that one as well. And we get 3x plus 1 and x minus 1 equals to 0. Again, set this equal to 0 and solve, so we get 3x plus 1 equals to 0. Take 1 to the other side, we get a minus, divide by 3, and we get x is equal to minus 1 over 3. Or, set that equal to 0 and solve, and we get x is equal to 1. Now we've solved it for x. Okay, so what we take from this grade 11s is just look for what's repeating and substitute it to be k. You'll get a nice equation like this that you'll be able to factorize, get it in terms of k, but then you need to back substitute for your k in order to solve for the x. Okay, let's have a look at example 2. So, solve for x, we've got x squared plus 5x over 2 plus 12 over x squared plus 5x equals minus 5. Now, you guys saw with the fractions equations, what we would do is multiply through by the denominator with the LCD. Now, just to take note here, if I multiply through by this denominator here, x squared times this x squared will give us x to the power 4, which is very similar to that previous example that we did. You guys can't solve for x to the 4 just yet. So we can see that we're going to use a substitution method. Also, we have this x squared plus 5x, x squared plus 5x, which is repeating. Okay, so we can use that k method that we've just learned. So, example 2. Just want to get it down. Okay, so as you can see, this is the thing that is repeating. So I say let k be equal to this x squared plus 5x. All right, so that becomes a k over 2 plus 12 over this becomes a k equals minus 5. Now, this is a lot easier to deal with. Just like the other fraction questions, we find an LCD. Okay, so we need the 2 and we need the k. I'm going to multiply each term by this LCD. So if I multiply this term by 2k, you can see that the 2's will cancel and we're just left with a k. So we've got k times k plus 12 times, and I'm getting the 12 from there. If I multiply this term by our LCD, the k's will cancel and you're just left with a 2 equals minus 5 multiplied by, now this has just a denominator of 1, so nothing is going to cancel, so we're just left with a 2k. All right, distribute to get rid of your brackets, so we get k squared plus 24 equals minus 10k. Take everything to the one side and set it equal to 0. So k squared plus 10k plus 24 equals to 0. You can factorize this. k, 6, 4 plus. Set that equal to 0 and solve for k. So we get that k is equal to minus 6, or set that equal to 0 and solve for k. K is equal to minus 4. All right. So now we've solved for k, but remember the original question is solve for x. So what we need to do is we need to now back substitute for our k, whatever we substituted there. So the k is now going to become x squared plus 5x. So we get here x squared plus 5x is equal to minus 6. And this one here we'll get x squared plus 5x equals minus 4. Okay, take the minus 6 to the other side. X squared plus 5x plus 6 equals to 0. And then we can factorize this. Set that equal to 0 and then solve, and we get x is equal to minus 3. Or set that equal to 0 and solve, and we get x is equal to minus 2. For this one over here, take the minus 4 to the other side. X squared plus 5x plus 4 equals 0. Factorize this. And set that equal to 0 and solve, and we get x is equal to minus 4. Or set that equal to 0 and solve, and x is equal to minus 1. Okay. All right, grade 11s, what I would like you to do for homework is exercise 2.3 for me, please. Thank you.